Oh, man.
Oh, man.
Exhausting.
Can you believe that? We've been laying rail for 2 hours.
2 hours in the hot sun.
Oh, my gosh. It's been a rough day, Orv. All that work, laying all that rail, 150 foot, and we still don't have enough rail to take off.
But that acceleration is so frustrating. This taking off business is getting to be a real problem.
Yeah, it just feels like Sir Isaac Newton is against us on this one.
Well, his laws are the law, and you have to obey the law.
Oh, I know. We all have to be good citizens of Sir Isaac. But this one, I don't know. You know, his first law, that's pretty straightforward. Newton's first law states that an object at rest will stay at rest, or if an object's in motion, it will stay in motion, unless it's acted upon by an external force. Well, our airplane trying to take off is the perfect example of that. The airplane's at rest at the end of the rail. We apply an external force when we turn the engines on and start getting some thrust from our propellers, and in response to that, we move down the rail. But the bad part is that unless we can accelerate fast enough, we don't get enough speed to take off.
Well, that's Newton's second law. Okay, that means that the force is equal to the mass times the acceleration. Well, we're interested in the acceleration here, so if we divide both sides by mass, we're going to get that acceleration is equal to force divided by mass.
Yeah, that's a nice piece of mathematics, Orv. It looks good. And I see your point. The math tells us that there are only two ways that we can increase the acceleration.
Mm-hmm.
We've either got to increase the force,
right,
or we've got to decrease the mass.
Right. That's going to work. Yeah. And I think we're only down to one way because I don't think we can decrease the mass. I mean, we've already made calculations to determine the size of the wings to get enough lift.
Yeah.
We've got the motor as big as we can get it to give us enough thrust so we can accelerate.
Yeah.
We've made this out of light materials. It's cloth for the wings. We've got wire supports. We've got thin wood struts. I mean, about every third time we land, we break something on the front end.
Yeah, and we don't even have any wheels on here, which is why we're on the rail.
You know, it looks like the only way we're going to decrease weight is if you fly in your union suit and barefoot. I don't think that's the problem.
Today it would be nice. Well, our external force, maybe the thrust. Now that's an application of Newton's third law of motion, the law of action and reaction. We take a large mass of air, we accelerate it to the back using our propellers, and in response to that, we get a thrust force that pushes us down the rail. Action, reaction. And that's all Newton's third law. So maybe the way I can make more thrust here is to move more air, move it faster, bigger propellers.
Bigger propellers? That we'd have to redesign the whole aircraft to make bigger propellers.
Okay, suppose we flew on only cold days. The air is more dense, then we could move more mass.
Well, that would work, but don't you remember our flights in December of '03? We nearly froze out there.
Yeah.
We've got to be able to fly year-round, Will.
And you know, it looks like we're just boxed in on this. As much as I hate it, I think our only solution is to make the rail longer. I've got some 2x4s out in the barn. Let me go out and see if I can find them.
Hey, come back here, Will. Hang on a second. You know, I think I've got an idea here.
You've got an idea. Hey, great, I'm all ears.
Well, maybe old Sir Isaac wasn't so bad after all. You know, maybe we could use him to help us for a change.
Okay.
Suppose we take those 2x4s and do you remember how he discovered gravity?
Oh, the falling apple story?
Right, exactly. What would you think if we took those 2x4s and we made some sort of a tower where we could suspend a weight and let the weight drop and provide a force to accelerate our aircraft?
Okay. I think it's going to take a little bit of engineering here, though. Let's see. We could run a rope from the weight down through a pulley, down to the end of the rail, around the end of the rail, back up, hook it on the aircraft. Okay, so then when we drop the weight, it pulls the rope. We get an additional external force that'll accelerate us down the rail.
Exactly, and with no additional weight on the airplane.
Oh, this is excellent. This is excellent. What do you suppose we ought to use for the weights?
Well, let's see. Sir Isaac, apples. We got an empty barrel. Why don't we fill it with apples and drop it down?
Very funny. Very funny. No. It's not enough weight. How about those iron bars that we've got out there?
Okay, that's a good idea. That's a good idea.
Yeah. Now the trick will be how we're going to get the iron bars to grip onto the rope when we lift.
Oh, no. It's not a question of how you grip it. It's a question of the weight ratio between the iron bars and the airplane.